Hello, everybody. This is OpenCV weekly webinar, and today we have with us Dr. Dustin Freeman from Meta Reality Labs, which was formerly called Facebook Reality Labs. So he is in the middle, literally in the middle of this tornado, this VR AR revolution. So he will have a lot to say. He will have a lot to teach us about this new form of human interaction based inputs. He's been through it. He knows the entire history, and he will tell us a lot about this. Dustin, we will come to your introduction in just a bit, but first let me introduce also Phil Nelson. He's the content manager at opencv.org, and he's responsible for putting together this webinar. As I always say, if anything goes wrong, it is because of Phil.
It is good advice in life and as in business. It's usually my fault somewhere down the line. Welcome, everybody. Thanks again for joining us. Greetings from San Francisco to wherever you are. If this is your first time joining us, there's a couple of things you should know. First is that we use the Zoom Q&A functionality to ask questions during the webinar. If they make sense contextually, we'll bring them up during the show. Either Satya or I will. We'll also save time at the end of the webinar for your questions that we don't get to during the webinar, the last 10 minutes or so. And there will be a giveaway of OpenCV courses. Satya, would you like to tell them what they'll win in the giveaway later in the webinar?
Yeah, so they will win the first course, Computer Vision 1, the Introduction to Computer Vision course, if you give the right answer, the first person who gives the right answer.
All right, yeah, thanks. So stay tuned for that at the end.
All right, so let's get started. Dustin, can you start with a quick introduction about yourself, a little history of your, all the work you have done. You have founded companies, and now you're at Facebook Reality Labs. So just a quick introduction, and then we'll dive into the presentation.
Yeah, I started grad school at the University of Toronto in 2008, focusing on initially kind of like what you might call gestural interaction on large tabletops. And a couple of years later, the Microsoft Surface came along, and then I worked on the Microsoft Surface, the Xbox Kinect, and then a series of other esoteric input methods. And then I spent a little bit of time working on AR headsets and telepresence. I think of that as a little bit more of like in the weeds when I decided that gesture interaction wasn't going to work. And then in 2019, I saw a demo of a gesture input system that actually worked, and I couldn't break it, which is very shocking. And I joined that company, and 6 weeks later, they got bought by Facebook Reality Labs. That
was
company,
it Leap?
It was Control Labs.
Okay, Control Labs. Okay.
Yeah, I'll get to that later. So historically, I'm not a machine learning expert or what you might think of as a computer vision deep expert. But my job has been working with those people to make something actually work. And the word actually is underlined, bolded, and it's it's adding all the other stuff to make it actually work. And it's kind of surprising what's required for that. Yeah.
That's great. That's great. So let's dive into the presentation. And also, at some point, some people, we have a lot of students who also join this webinar. Some people who are, thinking about a career switch, etc.
Yeah.
So from a Facebook Insider point of view, if you could give them a sense of what it takes to come to this, I know you got acquired, but it's
getting acquired is the best piece of advice I can say, but it's very difficult.
Yeah, but
I've worked at 8 startups, and one of them got acquired.
Right. But for people who may be wanting to get a job at Facebook Reality Labs, what do you guys look for, etc. So maybe towards the end we will discuss that question. So that it would be very useful for people. They may be thinking, how do you get from where they are, working at some company to get to the top, like in the middle of this AR VR revolution. So that
are we calling it Mang now? M-A-A-N-G? Is that the new one instead of Fang?
I've heard manga passed around. I'm not authoritative.
Manga. Oh my God.
Yeah.
Okay.
There's no word yet. So do you want me to go start into it?
Yes.
Okay, great. Here.
Yeah, let's roll.
Go. And I saw some people saying where they're based. I lived in Toronto for 10 years and then was based in the Bay Area for a couple of years. And then now I'm based in New York as of 2019. And so I called this talk The History of Body Tracking for Input Purposes. So the history, this is a very personal POV history. And but what I'm talking about is how we track the body and what the body is doing, the human body that we live in. Sometimes that's, you know, what we think of as vision-like, maybe involving photons or maybe involving like a 2D representation or something. And sometimes it's not, but a lot of the stuff is the same. And when I say for input purposes, I'm talking about, you know, when we do a lot of like machine vision or sensing work, our goal is to reconstruct ground truth labels, like, you know, bias towards accuracy. But what I focus on is like, okay, how do you actually turn it into something that you can use? So right now, I work at the group that was formerly called Control Labs that got acquired, and we work on, this is our research band that has been shown off in a few different blog posts. And we work on a variety of bands like this, trying to make a product out of it. And I can't really say much more than that because it's too premature and I'm just a guy. But that's what I work on. And that uses what we call surface electromyography or neuromotor signal detection, because when you contract muscles in your forearm, that sends a spike of electricity that if you build sensitive enough sensors, you can actually sense reliably, plus some machine learning, a lot of machine learning. So this is just gonna be some text. These are mostly notes to myself, but the takeaways I want you guys to have is vision isn't just cameras. Getting really good data is hard. Like I said, sometimes we bias towards accuracy, but you know, if you want to use, you know, a detection system for like real-time input, you should think about like, how can it turn into something that's actually usable? And everything pretty much depends on these three tricks. And I'll probably write this up and share this later. That is debouncing. When something is activated, making sure that activation state is sticky. Something called a 1 euro filter, which is a fancy way to avoid lag when you have a filtering signal, and hysteresis, which is, you know, another way to handle threshold crossing. Those tricks basically solve everything for you, and you can Google around for those.
It also sounds like a black metal album.
These should all be albums, and honestly, we could make a theremin out of them. It would be instructive. So I'm gonna do a bit of a motivation for why I got so interested in this, and it's gonna start a little bit weird, and then it's gonna make sense. I'm not gonna spend too much time on it. So this is an unrelated picture where I'm trying to type on a keyboard using a series of pins, and this is kind of where it all started to go wrong. So in 2000, as like any child, I really wanted to be an astronaut. So in 2004, I went for 2 weeks to this Mars Desert Research Station in Utah, where we simulated a Mars mission. So stuff that I learned about that. You know, I was like in a undergrad aerospace engineering program at the time. So I was like, you know, being an astronaut is obviously the best application of that. Stuff that I learned about that is, for my personality, I'm not the right person to send out into the field and follow instructions precisely. Whoever is gonna do that should be a really good instruction follower, because there's gonna be hundreds of people on the ground knowing what they should do. But the other thing I learned about that is like being surrounded by really like clunky equipment and trying to accomplish things in a body that like shouldn't be there. Well, we would wear these like artificial weights and masks and stuff like that and try to accomplish things. That actually really sucks. So the relationship of the body to stuff you're trying to do is like really interesting. I ended up switching majors several times. Here is a piece of mail that accurately describes that, trying to find me. Ended up working on applied math. And then I managed to send the most convincing email of my life to someone who accepted me as an advisor for my master's program. So I started off in 2008 using something called Diamond Touch, which is a large table with fairly precise touch interaction that has, it's similar to capacitive touch, but not quite, that has strips going one way and strips going another way. And if you notice a touch at an intersection, you can detect a touch there. You actually had to stand on these blue mats for the electrical signal to come through your body. But this is very early days of making an interface this large. And of course, it had no display in it itself, so you had to like project down onto it. So I did a lot of initial projects around, okay, what would you use this for? Is this useful? What are the requirements to bring it from this like prototype into something that actually works? I think this was made by a group out of Mitsubishi Electric Research, but I'm not 100% sure. And then,
In
of
other
course,
words, how do we monetize this baby?
Well, you know, the role I often find myself in is we made this thing, you know, not what is it good for, but can we make it actually like usable? So you might,
Doctor, what do we do with this?
well, so the role, often that role is thought of as like a product manager of like, think of how we sell it. And that's a little bit, even a little bit farther along, right? Like, it's like, okay, well, we made it, it like senses things pretty well. How do you actually make it usable? Like, what can you actually like do it for? And then trying to sell it is like try to sell it and what apps to actually build for it is kind of a later thing that I'm a little bit too artsy to be good at, but we'll talk about that later.
So Phil, just to add to it, if you have not heard Richard Feynman's quote, he said that physics is like sex. Sure, it has some useful purposes, but that's not why we do it, right?
Yeah.
So a lot of
point.
research is like that also. You know, sure, it can have some practical, real world applications, but the researchers themselves, that's not why they do it.
Good point.
Yeah, so my area of research is human-computer interaction. That's different from like, you know, machine vision or modeling. And the things that have worked out the best have been when there's been a tight loop. So it's not just people chucking things over the fence at each other. Here, try to make this work, or like, hey, this doesn't work, do it again. It's when you kind of establish a tight loop. So I'm not, like I said, I'm not a machine learning scientist, but I've learned a ton about it so I can provide useful feedback. Yeah, and there's lots of useful feedback. So Microsoft Surface is still one of the most compelling experiences I've like played with. This was in 2009 to 2010, while I was at Microsoft Research and while working on my own independent work. There's lots of like scenes and movies where people are like around a table doing stuff. This is from Battlestar Galactica, which is great, obviously. And we built so many of those like little fun interactions there, and it makes me sad. You know, admittedly, the ads for it were very dorky, but when you were around it, like, oh, it all made sense. If you sat around a table with like people with laptops, there's this distance there when you're not looking at the same thing.
Yeah.
So I had a background doing lots of like mime work for unrelated theater reasons. So the project they brought me in to do was to
unrelated theater reasons.
Well, we'll get into that. Actually, I think this will open. Oh man. Okay, this will open in another tab. Oh my God, what to watch an ad? Oh, I'm so sorry.
That'll be $10,000, please.
Okay. So I built this interface for teaching. Oh yeah, of course, because it's from 2010. It's in like 240p. I built this interface for like teaching really like high fidelity gestures. The idea is like, hey, we built this table that like can detect all kinds of things. How would we like tell people what gestures to do at which time? Let me jump ahead. So I built all these like sort of interactive visualizations that show people what to do, going to give you live feedback. Almost like if you're kind of doing like imagine if you're doing surgery on something and you're giving like, hey, this finger is off by a couple centimeters from what we need to detect a certain gesture. That's sort of like really high fidelity interactive feedback. So this is, you know, this is an interesting project. I'm glad I did it. I have since become way more skeptical.
This was a camera looking down at the hand and the gesture would be on the table?
No, this is a Microsoft Surface and oh, right. So this is on the Microsoft Surface and we're looking at a camera down on the table.
Okay, so the camera is not actually doing the gesture. It is the surface, contact with the surface, which is doing.
Yeah, it's just a dumb camera. Yeah.
Yeah. The Microsoft Surface table was something called frustrated total internal reflection. Which
could you explain what that term means?
It describes me right now, that's for sure.
So when you take a band of glass, you know, it's very similar to fiber optics. And actually fiber optics work this way. If you shoot a laser down a thin channel, before it approaches the edge, it'll curve back due to the way the index of refraction works at the edge of fiber optics. But also even within a table, if it's at a very narrow glancing angle, it'll totally reflect internally. So that's called total internal reflection. But if you place anything on the surface, it makes a fairly tight contact. So not like if you just dropped a shirt on it, this wouldn't make as much difference. But if it makes a fairly like close contact, it frustrates that total internal reflection, which means that it scatters light down. So if you have the surface here,
Yeah.
it's full of light. You almost can think of it like you're filling it full of light.
Yeah.
And then you have a camera underneath.
Mhm.
It doesn't see any light until someone places a finger on it or another prop that it
Got
makes
it.
light contact, and then it glows very bright. So that's one way that allows you to make like very large tables,
Mhm.
and that allows you to get fairly high fidelity view of the point of contact. So unlike this diamond touch thing, which required you to like stand on these pads and would only detect things that conduct electricity, like humans.
So that's because of this mechanism, the touch signal is converted into a binary mask. Is that right? Or is it?
It would be, it's effectively binary. Yeah, pretty much all the input we used it for was binary.
But it could do some amount of, just like a lot of surfaces these days do. You can actually understand the pressure also, right? Just because,
yeah. And that's just because of the size of the blob, because your fingers are squishy. So that actually worked incredibly well. So we got all sorts of things, like you could get things like finger orientation. If you're hovering close to it, there would be sort of a blurry blob. So if I like did this on the surface where these two are touching, I could infer that it's these two fingers, not these two fingers, due to the shape of the kind of gray blob behind it. So lots of really magical stuff. I did a ton of work on it. I did lots of user tests too. And this is sort of the first taste I had. This is a great anecdote. This is sort of the first taste I had of like how gestures in the wild work. So first off, these are people that Microsoft recruited randomly, and often the first question they'd ask me is how they could redeem their coupons. And I'm just like, hey, I'm running these user studies. I don't know, you need to talk to your point of contact or something. And so that's like interesting, running user studies. But one lady we had this gesture that went like this, and one lady had incredibly long nails and just couldn't do it without this like scraping noise. So I had to like listen to this scraping noise for about 15 minutes. That's terrifying. Another guy came in and it just couldn't see his hands. It couldn't see his hands. I ended up like opening up the debug video view, was digging into it, was unsure if there was a bug. I went over and put my hand on there. My hands showed it very clearly. And so I asked him to go, was he doing anything the day before, or could there be something residue on his hands? And then he washed his hands and came back and his hands were clear. And so this is a graph of the infrared absorption of gypsum, which is a component in drywall. And he was a construction worker and had just come there right from like a job site, and his hands had a light dusting of gypsum on them, which no one noticed, but an interesting thing to observe that was sort of invisible. So I worked on lots of interesting prototypes for this. This is a case of a prop that we put on the interface that would detect, it could detect not just my finger, but it could detect that this prop was there. And here's me. We actually there's fiber optics coming out of the head of this guy, so we can it passes through like graphics from the surface itself, which is just a crazy thing you can do. And this is just another fun thing you could do with the surface. So this is of course mounted up and sideways. So I built this kind of crazy table because I wanted to play with different orientations. This is what happens when you're in grad school and you have a huge budget. This is a mocap system. And so like for a lot of these things,
could you zoom into that mocap system? I don't think.
Yeah, let's see if this works. Okay. Yeah. This is a Vicon motion capture system, which is on some of these tripods here, and there's some of these retroreflective markers here. And this is a WPF application, which is a dead Microsoft UI library. And there's Vicon markers here, and I also ended up wearing a glove when operating the system. So we mentioned before, like sometimes some physicist will, make something and kind of toss it your way and figure out how to make an interface out of something. Sometimes the opposite thing works, where we try to say like, okay, assuming we could track something with really high fidelity, could we do anything with it? And that's the opposite. Sometimes people call that a time machine. And so in this case, we would use motion capture as a time machine. So let's say not only could the table detect touch, but what if it could detect my hands a little bit above the surface? And so I built.
That you're about to touch it.
Yeah, you're about to touch it or you're pulling back. So in the like, oh my God, I'm so sorry about these ads. In the 5 to 10 centimeter range. So there's like a live, like I'm looking in a mirror, like a live reflection of my hands. And I'm like interacting this like it's a file system of a bunch of photos you can drag around, which is of course very in vogue from the years 2009 to 2012 when you're demoing these kind of things.
Yeah, I remember Bump.
Yeah, Bump was built in the room this video is filmed from, because it also was from the University of Toronto. Yeah, we had the same. We're talking about Bump Talk, right?
Absolutely.
Yeah, we had the same supervisor. And so here's a odd situation where I'm actually moving around my left hand using the mouse, but then I can also directly reach, and then my hands sort of act as two independent clipboards. So I can grab something, go to type, and then like release it later. And so this is me playing with embodiment as sort of a time machine. The weird thing is like, this was kind of cool and I could build a demo video, but like, I didn't feel quite there. It didn't feel quite right. Like, and I have a lot of existential crises all the time about things I build, and I like stop and switch to something else. And sometimes you run into these people in the human computer interaction field. And if you're not careful, you will bias towards building cool demos and not making anything that actually works. And I'm not talking about a product. I'm talking about research too. Something that like demos well in a 90-second GIF or something like that doesn't necessarily feel good. And with something that's like really interesting is the things that feel the best sometimes demo really poorly.
Yeah.
So
yeah, things that are heavily experiential that you kind of have to feel often just don't come through on just purely video and audio.
Yeah. So the interface I'm working on now, which is this neural interface, is highly sensitive. So when you're using it, your hand barely moves. It actually doesn't look like anything is happening, and it generates these incredibly boring demo videos. But then again, that means we internally built a bunch of systems that makes it really easy to try out demos, which is great. It's a great response to that. This is if you were curious, this is me tearing apart the Microsoft Surface that Microsoft sent us that I carefully reassembled without breaking. And here's what the cameras looked like on the inside. So this is the underneath I couldn't actually find any photos of this on the internet. So this might be like, might be the first time. So this is what it looks like underneath the table. And there's these black and white strips here because these cameras.
Reflectors, yeah.
Well, these cameras need to calibrate themselves relative to the top of the table. If you actually, let's say the table was transmitting a static graphic. If you kicked the table, that graphic would like shake around a little bit. Yeah. In the range of 4 or 5 pixels, which is not something like an LCD does. Like if you like knock an LCD, the pixels don't shake around a little. I think did cathode ray tubes used to do that?
It depends.
Yeah.
It depends on how well they were assembled.
yeah. But it was very funny. So one thing that was frustrating is this table was also full depth. So like you couldn't get your, this will be a relevant graphic, but you couldn't get your like knees underneath it, right? So every time you had that like intimate commuting experience with someone else, you would still be like also full straddle, your legs as wide as possible so you get
akimbo.
Yeah. So this interface was great.
What we are looking at, these are this is the internal camera.
These are 4 infrared cameras and then 1 projector that come up from inside the table to look at this screen that I've removed.
Okay.
Yeah. So this was great, but it didn't really go anywhere. There was a vision we had in 2009, 2010 where like, hey, maybe every table in the future will be interactive. It is a pretty good vision. It makes a lot of sense. It would be compelling, but they couldn't get the Surface cheap enough. Also, they didn't really want to. I mean, I was just a dumb intern wandering around, but I ended up in a room one time where they had one of those standard like micro econ graphs of like the price of the Surface and how many they could sell. And this point was like $5,000. And I just was like, okay, well, this kind of sucks. I wish that someone had come up with like a $1,000 version or like a high-end kind of console kind of version. And it just didn't really happen. And the thing that was magical about this again is like I could be working on something and someone could go look at it and immediately share it. And this just doesn't happen for laptops today.
Right.
And we kind of missed that boat. And
Yeah,
now,
I think for a lot of these products, right, there is if only one company has come up with something, and there is a market education that needs to
yeah,
happen, it's very difficult to pull off a lower price, right?
yeah,
But if the whole market is moving together, which happened with gaming, GPUs got better, and now with the same GPUs are being used. We basically, the AI people started using GPUs, and that's a free lunch, right? We got high computation almost for free. But if the industry together moves in that direction, the components, and I see the same thing with LiDAR also. The LiDAR on the phone, on iPhone 12 Pro Max or 12 Pro, it's I don't know how cheap they are, but they are in a phone. These used to be thousands of dollars just a few years back.
And that's actually really relevant for something to do with neural interfaces, which I'll talk about later too. But this table was definitely like over featured. Like, it had 64 touches. It could see like 5 or 10 centimeters above the surface. It could detect props. I just wish that they had made like a cheaper version of it. And then
I missed how you actually detected things over the surface. Was it the projected camera system?
So the FTIR table, it does have a little bit of leakage. So a little bit of light does get out. So if you bring something large, like a whole palm, within 2 or 3 centimeters, maybe 5 centimeters, you can kind of see that there's a sort of ambiguous blob there. You wouldn't use it for detecting anything because it's there'd be too many false positives or ambiguities. But if you see a couple fingers near there, and then you see the centroid of the blob, and then you see the orientations of those finger blobs, you can kind of infer where the hand is, and then you can figure out, well, is that the index finger or the ring finger? And it actually worked really well. There's a few papers you could find, not by Microsoft, by other people, but yeah, it actually worked really well. And so you can do stuff.
It was actually a bug. You probably don't want any leakage. I don't know whether you actually want the leakage, but it was not preventable. So that was actually used for this cool feature.
Yeah. I don't know the story of whether, hey, we can spend $50 to prevent the leakage, or we could not do that and do something else. I don't know. But like, people could build demos, like you could do MS Paint where each of your fingers would pick up a color. And so I could like grab red and green here and then start painting red and green with different fingers, like I'm finger painting, and it just kind of worked. It's very magical. But anyway, so this table, technology comes and goes in and out of fashion. We know that there was like 90s VR that kind of went out of fashion. And then, it managed to come back thanks to cheap mobile displays that the Oculus depended on. If we hadn't spent a decade optimizing mobile displays, we wouldn't have been able to do modern VR. But the thing is I don't think we're going to get large tables again. I think we lost out. When the Hindenburg crashed,
are you gonna? Is this gonna be a lamentation on the death of dirigibles as an industry?
Yeah. That's where I'm going with this. When the Hindenburg died out, it was due to hydrogen, even though helium was possible, but it kind of scared people off for a while. But in that time, heavier than air airplanes, or heavier than aircraft, came along, and everyone focused on those, and those were kind of good enough, and it didn't really make sense to bring back dirigibles. If they had competed fairly, I'm pretty sure that in 2021 I could probably buy a dirigible airline going to Paris or something like that right now.
God, it would be so awesome if we were traveling around on Zeppelins, man.
Yeah, so I think we kind of lost out on that, and I kind of feel the same way about the Microsoft Surface. Like now, headsets are just too easy. They're just too easy, and they're going to be too cheap, and no, it won't make sense to make a table. And I was very excited when Tilt 5 came out, or is in the process of coming out, because I was like, yes, I can make that round the table experience again.
Yeah, they're coming from the opposite angle, basically.
Yeah. So I did my master's was on this. Speaking of ideas that maybe
we know all your preferences now.
I'm not logged in. I've never smoked in my life. So I had this idea where I was going to do what's called just-in-time programming on the table. So every time you do something, it kind of initiates a repeatable copy of what you've done. If you've used the Scratch programming language, this is really similar to that. But it's kind of like if you've used undo operations in a modern computer are kind of like a stack. So what if that stack was available to you and you could tear things out of it? And so this is like what my master's was on. And if some other people have tried to do something a couple decades ago and then stopped, you should beware if there isn't a reason why it works now. So a lot of my citations for this project were from this area of work called programming by demonstration or programming by example, which is like really in vogue in the 90s. And I was like, a naive person in like 2011 was like, yeah, what if large tabletop surfaces are what will make programming by demonstration actually work? Well, it just was kind of clunky, and it was just way too cluttered. I'm gonna see if I can find examples here. Yeah, it kind of makes this kind of mess of all this like junk that was too messy to do things. But this is me trying to be like, okay, what could you actually do on a table that isn't moving photos around, that actually feels like a task you'd want to do?
The UI reminds me a lot of Game Builder Garage for the Nintendo Switch, which is a fun kind of, basically it's a demonstrative programming app for the Switch.
I don't know
yeah.
I really like the Incredible Machine, obviously.
Yeah.
So, but let's move on to vision stuff. So then I got into whole body interaction, which when the Kinect came out, the timing was great, just as I was getting kind of like, maybe these tabletop things aren't that exciting. This is the 2009 E3 presentation where Kinect was launched. And we're gonna watch this video really carefully when I open it. And like I said, my overarching theme is like, what makes gestures actually work? And what's realistic behavior? And how do you bring something from like a proof of concept to doing useful stuff with it? So we're gonna watch this guy. And we're gonna probably watch an ad first. Okay, when you watch, this is the first demo. I want you to watch his hands. This is the first time the demo was shown live. This guy's obviously a very experienced speaker. So he is used to gesturing emphatically as he talks, which is what you do on stage. That's a built-in part of his experience. But if you notice, he's obviously done, what was that? He's obviously done a lot of run-throughs of this presentation with a lot of people. And he's repeatedly gotten the direction, bring your hands back to your legs. So you see he wants to do these emphatic gestures, yeah. But he's been told, keep your hands really close because it'll screw up the system. And we're probably running a beta version of this software for the presentation, so it's maybe not even final, but even then. And so this is a really great example of like people who build these tools internally get used to working around their finicky behaviors and kind of whether he was told this or whether he just got used to this implicitly. So when I was working,
this is gold.
Yeah, it's weird. Yeah. When I was working,
I'm just imagining. Yeah.
Yeah. What? Go on.
Just imagining the, how many times he probably had to do this, and
yeah.
Going back to your performance, background as well, you can. It makes sense that you would key in on that too.
It's weird, right? It's noticeable. So people around Microsoft Research,
and this poor guy, it's just him doing a good job.
Yeah, he's doing a great job. People at Microsoft Research, when they would touch the surface, they would do this like touch like this, right? They would do these like really weird pronounced touches because they've been practicing it for 2 years. And when I brought people in for user testing, they would do, if you ask them to grab something, like I would grab a phone here. Oh God, that's my mask. They would do it like this. So just their entire skin would sloppily come in contact with something, it doesn't work. So, what's the way to react to that? Do we make our interfaces robust to all that human behavior? Or do we train our users to be slightly better? That's obviously a huge contentious thing. A lot of people say this, a lot of unhelpful dogmatic nonsense, like, oh, everything should be walk up and use, everything should be intuitive, which doesn't mean anything. People learn to use microphones over time of like, oh, how are you too loud? Are you too soft? We're not necessarily fixing microphones. Maybe we do some auto balancing, right? But like, there is always a little bit of a learn to use, and that's okay.
And still, there's also even, the professional level stuff is you don't want to do the auto stuff because it will break it.
Yeah. Let's move on. So I did a study at incorporating the Kinect, studying this actually might be a nice embed. Yeah. So basically, I was like, my research project was like, hey, we want to know what it's like to use the Kinect versus like a Wii-like interface. So I hacked together a bunch of things with an IMU when I said we, I mean like a Wiimote, because the Wii had come out just before and the Kinect had come out later. So I built this version of table tennis where you could play it with a regular paddle, with 6 degrees of freedom, 3 degrees of freedom, Kinect like just by, with a hand or by holding a stick. And so I would also like mess with things like, I'll give you a stick to hold, but it won't track the stick. It'll kind of assume, it'll do like a little inverse kinematics, and pretend that it can detect you, but actually it isn't, which a lot of these systems do anyway. And so the interesting thing about that is people that held a physical prop, if they held a paddle and it wasn't reactive to them rotating it in 6 degrees of freedom, people would notice it. But if people just used their hands and it wasn't reactive in 6 degrees of freedom, they didn't necessarily care. So there's kind of this like fidelity matching that happens, right? If you if you make someone believe that it should be responsive, they expect it to.
Well, yeah, there's cognitive dissonance with what you're seeing in your hand and what you're seeing on the screen, and that's always gonna, take people out of it.
Yeah. And I didn't care necessarily if they were better at playing the game or something like that. I just was interested in like what's the experience of this. So this was very early. This is 2010, and so to get skeleton tracking off this device, I had a developer version of the Xbox. So that was the XDK, and I wrote a little like app for that, and then I sent that over WebSockets to a PC, and then used XNA, or the Microsoft Game Engine, to write the results to a CSV file. So I built this like crazy setup, and there was this weird thing that was happening at Microsoft that time where for some reason the like Xbox Connect people weren't talking to the Windows Xbox people, or the Windows Connect people. And so like someone from the Windows Connect team like reached out to me, an intern, was like, hey, we heard you have it running on Windows. And I'm like, I'm just bringing it over WebSockets from an Xbox developer kit. Why don't you have a contact on the Windows or on the Xbox Connect team? What is going on here?
Like, why aren't you all on the same floor?
Yeah, it was very strange. Here's another interesting video from, or a picture from that time. So there are a lot of setups involving multiple Kinects. And so the Kinect uses something called structured light, where it shoots, in the structure sensor, callback, it shoots a pattern in infrared and then observes that pattern from a small displacement, like 8 centimeters. And then based on the individual alignment of each of the dots, it can infer how much of a shift there is. So unfortunately, if you want to do a full room, one of these cameras can only see something in a small frustrum, and I'll complain about frustrums later. But if you want to do multiple Kinects in the same room, that means that their dot patterns will interfere with each other.
Yep.
And so what someone did.
Can I add one more thing to it?
Yes.
So that's called structured light, right? When you project a pattern and you have a projector camera system, the camera actually tries to detect the pattern, the original shape of the pattern, and therefore you are able to infer the structure. Now, there is another concept called textured light, which is, it's actually in those kind of concepts, in those kinds of systems, people actually have a stereo system. You have 2 cameras, and on walls which are plain and create problems because they don't have any texture, you simply project infrared light. And in those systems, you could have multiple cameras looking at the wall, and because it's just adding texture to the wall without, you are not able to see it, but the cameras are able to see it. So some of those problems are solved using textured light. You have stereo systems, and you assist the stereo system to look at plane surfaces by projecting textured pattern, and it doesn't interfere. You could have as many textured light as possible because they are not interfering with each other. They just add more texture to the wall and help the stereo systems. Yeah, now you can continue.
Yeah, it's really good that we came up with that fix. This fix here is 2 Kinects on top of each other, and one of them has a spinning weight attached to it. And what that means is that the Kinect on top is vibrating slightly. So from its POV, its projected structured light, all its dots are sharp, but from the other one's POV, they're blurry.
Nice.
And the opposite is true.
Right.
So the components within the Kinect are mounted securely enough that if it's vibrating slightly, it doesn't cause a problem.
Wow. That's a clever one. I would not have thought about that. It's a very clever one.
It was very stupid, but it made everything work. I can't remember who came up with this, but it's very dumb. And this is because we often would like set these connects up and kind of leave them somewhere statically. Other AR systems, like when we were doing stuff with a structure sensor, they were kind of always floating on an iPad being held by someone or a headset. So they didn't run into this problem because they would have this like slight Brownian motion as long as you were moving. But this is one way people got around it. So anyway, I was very fortunate to be on this project called Connect Fusion, which actually 10 years later won like a lasting impact award.
Good old Kin Fu.
I was the youngest person on this project of very illustrious people, but part of my job was like, okay, how do we actually explain to people how new this is? So this is real-time SLAM. This is one of the demos I built here where
and remind everybody what year this is, Doc.
This is 2011. So this is this slammed the background, and then I jumped in, and then it would slam me. And as long as I stayed rigid, which is me rigidly rotating here with my legs at a fixed angle, then I would be kind of real-time constructed. This is running, I think, on 4 GPUs at once, because things were different back then. For this project, I had to write C#, C++, and CUDA all at once. In this case, this is another demo that we wanted to show how quickly the mesh would adapt. So someone had written this particle thing, and then I grabbed a little Matador cape and was like flipping it around like that.
Neat demo.
So I have this a minor regret in life. In my final year PhD, I had the opportunity. I got selected for doing an internship with Dr. Richard Zaleski and Dr. Singbing Kang, who were at Microsoft Research. And this was like, the best thing that could happen to a grad student getting an internship there. And 1 month before I was supposed to join, I actually, I was starting a company also at that time. And I had to bail out 1 month before. It was kind of sad. But this was Microsoft Research. I always felt that they were doing so many cool things, right? But many things did not come to the market. Connect was one that actually made it to the market. But Microsoft Research was really it was like Xerox PARC for computer vision at that time.
Yeah, and I mentioned earlier, beware about the bias towards demos and bias instead of making things actually work. And that's one thing, I'm not criticizing any individual necessarily there, but like I often observed everyone, paper writing academics are biased towards making writing papers primarily. And if it's hard to transfer that tech elsewhere or validate the usage of that tech, it sort of dead ends somewhere, and it doesn't necessarily hand off to a team who could actually make it. So, that anecdote is that the team reaching out to me, an intern, hey, do you know how to like transfer this to this other machine? When I'm like, why don't you have a direct contact? What's going on there? So I kind of, let me skim through some of this stuff. So I went to work in 2009 at Hewlett Packard Research India in Bangalore. And the goal was, let's build an actual practical interface to operate things in a living room. And this gets really interesting. And I had like lots of early enlightenments here. So the UI they built, that they built detectors for, was a set of gestures, left and right swipes like this, up or down, what's called an air tap. And forget the rest of what I wrote here, but those are the 3 gestures they made. And so what they wanted to do is they wanted me to, validate that this is actually the right thing to do. So one of the first things I did was like what's called a Wizard of Oz evaluation, where I give people a task on a screen. I watch what they're doing and I fake it. So I fake it with like keyboard buttons. They can't see that I'm actually controlling it. That's a really common thing to do.
That's interesting.
Yeah, pay no attention to the man behind the curtain.
Oh, so it's actually not working. But if you see that they did the right gesture, you would just do a keyboard thing. Yeah. So they feel that they're controlling it.
Yeah, it's one of the ways. It's one of the ways to, if you don't require a ton of responsiveness in the interaction, it's one of the ways to validate that you at least watch how people are going to do it. Because there's a horse in the cart situation of like,
Right.
how do we build a model if we don't know how messy real behavior is? Or if we can't observe what people are going to do in the wild, then we're not going to be able to build an effective model. So Wizard of Oz is great to go. Some of the first Wizard of Oz techniques were actually for command line interfaces, where it'd be like a chat terminal, and someone would be like ls this directory, and someone would write what was in the directory. That's one way to do Wizard of Oz. Anyway, one of the things I observed was that no one would do the gestures as precisely as this group of like machine learning people had defined them. So they defined the gestures as, well, your palm hand has to be pretty vertical, and then the motion is left to right, right to left, up or down, and then a tap forward. So first off, the like vertical palm was like what everyone expected. If you try to do that, like it's obviously painful. But what had happened is, the researchers were building like a palm detector and then like a palm angle detector, and we're like all testing it in front of their screens. And they're like, yeah, that seems reasonable. That seems right. And they just were ignoring that, hey, this is actually pretty uncomfortable. That's one thing. Another thing they were doing is like, what's easy to detect? You can detect a palm. What's easy to detect? Well, obviously the three directions. Those are very discriminable. Those are three different things. But then I like watched how a bunch of people perform these things, and but bam, everyone rests their arm on something. And so what becomes a 3 degree of freedom interaction actually becomes like a 2 degree of freedom interaction. So, right. Left and right is still fine, but people would be prompted to down or forward, and it would be
right.
That's the same gesture.
It looks exactly the same as your swipe gesture. Yeah.
It's maybe the palm is slightly tilted down, but it's the same. So, the problem isn't necessarily, maybe that's solvable with machine learning, but the problem is your training set has nothing to do with what people are going to do in the wild.
Right.
Nothing. So that was a really interesting observation. I'm going to skip over this because I want to get into other stuff, but I did build a version of Tetris that you play with your body. I'm going to talk more about noise. So DGP was the name of my lab at the University of Toronto. To try out some more of these ideas, we built a doorbell with instructions of what gestures should do. And so we had this recurring problem, and there was no doorbell for the lab. But if you want to contact a single person, how do you do that? So we got like a name directory, and if you like purely operate it with the connect, it would send a picture of you to the person you were trying to contact. But these are all hand gestures, right? So you need to hover over certain buttons on the 2D interface to trigger them. But there's not necessarily like intentionality there. Your hand's just in space, right? So, I got this, I got one of the professors got an email 500 times because his last name, Eugene Fume, his last name was the mean middle of the alphabet for all the people in the lab. And when people would hover in front of his name and go back and forth as they were talking, it would trigger the send picture button. Yep.
Cautionary tales of mailing.
Yeah. And that's in 2011. So that's, it's important to build things and see if they actually work. So I embarked kind of on this like serious project of like, okay, well, obviously nothing's good enough. Let's actually try to get the messiness of real behavior. So I built this lab setup. I gave people stuff to do. I like brought in 13 groups of 4 people for like a couple hours, gave them all this like snacks. I put connects around them, and then every 30 seconds or 90 seconds, I'd prompt them to do a specific gesture. Some of them I'd track with motion capture. And the goal was like, not only are we going to get like messy gestures while people are in the middle of things, we're also going to get a good amount of what we call background activities. That's like, real stuff. Some machine learning researchers might call that a null class. But a null class is slightly different. It's like a null class is like where nothing's happening. But we wanted to get like, okay, what's like realistic activity look like? Not for body tracking, but for gestural movement. And so I'm going to try to skip ahead. We have all these like really kind of perfectly messy examples. I think all these people are prompted to do, oh yeah, these are all false positives. So that when that guy reached down, when that lady brought her shoe over, that was a swipe false positive. That when he carried when he moved those over, when he reached his hand like that, I think there's just tons and tons of false positives. And this paper was really hard to write up. I tried to get it published 5 times. But basically the outcomes of the paper were like, hey, nobody's doing realistic enough data. Here's how bad state-of-the-art detectors are on this data. I'm not making a new detector. I'm trying to make a new data set for you. And ultimately, I realized I wasn't necessarily like into trying to be a data set person. It was kind of dejected. And this is sort of when I decided not to be an academic. But I moved on to, we're low on time. I moved on to building an interface for what you might call like live video DJing on like a theater stage. Let's see, what's the best thing to look at here? Yeah, so imagine you're able to do kind of like live video editing and remixing while you're in the midst of like acting. This is like using my theater background. And so I had to build lots of little delimiters, lots of debouncing, lots of like clear feedback and state changes, so that people could make something actually usable. And this interface looked very dumb and clunky, but people could actually use it and build pleasurable things with it. And while they were in the middle of like acting. So that was my experience. But then
very interesting. Can we so hey Doc, we're gonna pause here to do our giveaway and then come back to your so you're not rushing through. We can go a little bit over, but we want to make sure that people that stuck around for free OpenCV courses get their opportunity here.
I respect that.
Do me a favor and go ahead and unshare your screen real quick while we do this part. Okay, so thanks, Doc. For if this is your first time here, or if you just need a reminder, the way this works is I'm going to ask a trivia question based on the slides so far in the presentation from Dr. Freeman here. The first person to answer this correctly in the chat in my little Zoom window here will win. Satya, would you like to remind them what they'll win?
Yeah, so they will win Computer Vision 1, which is the introductory course on computer vision from opencv.org. And just in case, some of the people might have already taken that course or something like that, just tell us and we will swap it with any other course you want. For example, you may be interested in deep learning with PyTorch. So you will get one course free, whichever you choose.
Awesome. Yes. So get ready to answer the question here. Again, just type it in the chat, or please just use the regular chat window so that way I see who's actually first and don't have to go through the chat log later. So early in the presentation, Dustin mentioned using a tracking system in grad school from a specific company. They're still around and they're still used on TV shows like The Mandalorian and stuff like that. What is the name of the company that made that tracking system? Dave Wong. Looks like Dave Wong got it first. That would be Vicon tracking. Congratulations, Dave. Please send one email to phil@opencv.org and we'll make sure that you get your course of your choice. We can continue with the presentation now, Doc.
And there is no need to rush now because this recording will also be available for people who have to leave at 10 o'clock. Okay. So we can go at the right pace.
I mean, I have other things I want to do, so I don't think it's going to be like another half hour or something.
Fine, Doc. Jeez.
After this project, I was like pretty dejected about gestural interfaces. It was hard to convince people that how good the data needed to be to make it actually work. Most things are vision based, and so the range of their view is limited. And I mentioned frustrums again. And a frustrum is this shape around a camera. You can make it wider, but you're still missing part of the world. And so they work really well when you're in the range of the camera. But are we living in a future where, in some of my delusions, I was like, well, cameras in rooms are going to be as plentiful as power outlets. We'll just have them all over every room. And that's not going to happen probably in this timeline. And another thing was Yeah, it was just really hard to convince people how good data had to be. So like I'd see lots of like very confident presentations that would say, you know, a 95% detection rate, which is 1 in 20. Imagine that you're trying to type and 1 in 20 you get right.
And you were yeah, that's bananas.
Yeah, and that's 95% detection rate on the clean data. So that's the data where like a researcher is doing something like this, right?
Right.
And so that's just not, you know, it's not realistic. You know, it's the, in one case, I think in the background activity study I ran, there was one gesture that was detected like 0.3 or 0.4 of the time. And those are very simple gestures. So, but let's remind ourselves why gestural input is good, or it should be good. So the fact that it should be always available, that you can do things without having stuff in your hands, and it allows you to not have to go to the interface. So our interfaces currently require us to come to them. You know, even our mobile phones require us to arch over or pull our phones out of our pocket. You might also say way, like,
I mean,
and that's not to mention all the constant looking.
Yes.
No, so for that reason, I actually really like Alexa, which can do a few things for you without it's constantly on with an, you know, not constantly, but it's at least looking for the word, you know, hey Alexa. And then you can do a few things with it. It's very convenient. Obviously.
I wonder how many people listening's Alexas just went off.
No, they changed that after that. Jimmy Kimmel, I think, did this joke, or Mark Rober did this joke. I can't remember who did. Yeah, on the TV they said, "Hey Alexa," and they even put something on the shopping cart or something. It was hilarious.
According to Martin in the chat here, you did in fact trigger his Alexa.
Oh wow! Hey Alexa. Sorry.
So you know, one might think that hey, these any input that involves a machine learning model. So hey Alexa is a good example of something that like or hey Siri is a good example of something that like you don't need to do that thing in a hurry, right? Like that's something that you're okay taking a long time to do, but anything that requires direct control, like if I need to enter a sequence of actions or if I need to do something fast, you want pretty direct, reliable control. Yeah. And so you might think like, well, why would I do anything with a gestural interface or anything that requires a machine learning model? Because those are inherently probabilistic. So there's some probability that they'll get it right. It's not 100%. Why not just make a good button or make a good controller? And especially you hear people saying that who especially are into like, you know, high speed, high performance gaming, or like they have a really fast typing rate. And that's, you know, that's accurate. But I want to convince you guys that every interface is probabilistic, you know, even buttons itself, no button is 100%. And if you look at how debouncing is done for like electrical buttons, there is a sort of like parameter tuning that happens in the capacitor that put in a button that like where they sort of determine what the right time is for the threshold to cross from 0 to 1. And that is a subjective thing that people kind of come up with.
If you don't mind, could you explain the concept of debouncing? There are a lot of people who are.
Yeah, I'm sorry about that. I should have included a graphic. So when you flip a bit from 0 to 1 based on something being detected, even for a traditional button, which is two electric pieces of metal coming into contact, there's a moment here where it gets really close and it gets into contact and goes out of contact and gets into contact and goes out of contact really, really fast before it becomes in contact, right? And you definitely don't want to be sending a signal where it is where it's going on and off really fast within the space of like a few milliseconds. It should just transition from 0 to 1. So it's one way of thinking about, you might call it a filter in some sense, but it's a way of saying like, okay, once you flip from 0 to 1, don't flip back for a certain amount of time. Yeah. That's how you'd like implement it in software. You'd say like 20 milliseconds is actually usually good. I use that number a lot. In electrical hardware, you just use a capacitor or something.
Mm-hmm.
Sort of like a mutex lock, basically.
Yeah. So when people perform gestures, they are also very messy, right? So a button is a little bit more ambiguous. If let's say I have a gesture that's a thumbs up, I might do something like I might start the thumbs up and then kind of like think about it and then change my mind. And then that that intention, which is a messy intention, because real life is messy, doesn't necessarily exist in some sort of training data that trains a model on. So it's really hard to get like accurate models. Let's talk about that. So I'm going to skip over this. This is a couple things I did while not working on gestures for a while. I worked on this with Phil.
That's a couple things. Yeah, it's something we did.
Something
in fact, I remember editing that. Was it CES 2016? That's what it's. Yeah, CES 20. We were editing that at the show.
I also had a concussion at the time. It was a rough time.
I remember that. Yeah.
I also worked on Bluetooth beacons for immersive theater, and this is a cautionary tale. Just because something comes on the market doesn't mean Murphy's Law is going to make it good anytime soon. So these would give accuracy within 4 meters, plus or minus 5 seconds, and you're like, okay, yeah, I can build an experience with that triggers audio at different times. We sort of built a choose your own adventure as you walk around a room, and this was vision-free AR. So you plug in headphones and your phone in your pocket, and you would walk around and be like, okay, you're at the piano now. Now, if you want to follow this character, walk to the phone. If you want to follow this character, walk to the bar. So we built like a little Twine-like experience. And we were like, okay, great. This technology just came out. It just became available in phones. It's obviously going to get better in the next generation of phones. It never really got past plus or minus 4 meters, plus or minus 5 seconds, which is too bad. I worked on this a lot. I founded like a company with a game writer in the UK named Rob Morgan based on this. And we did like lots of like clever script writing that's sort of Twine, like Twine, but with really clear instructions. And then I ended, and that company was called Playlines. And then I ended up like buying all these stupid phones, and then trying to do all these like calibration tests to determine the accuracy. And I was going to build like a per phone machine learning model, or something, and just it didn't work. And it also would be dependent on things like where you held it in your body, because the human body is attenuates radio signals. And also we were both men. We had pockets. So it would go next to our phone would go next to our leg. Women would put on their headphones and then stick it in their backpack. And then the signal quality would be different. So if a trigger was supposed to trigger when it was detected 5 meters apart, maybe for women, we would actually need to change that to 2 meters. And then it wouldn't trigger, and all sorts of dumb stuff happened. Yeah. So cautionary tale.
Cautionary tales of sensors. Sensors are dangerous.
Yeah, I mean, and just don't trust any hardware manufacturer to support something that is new. So I remember we tested this in occipital. It was like the iPhone 5 or something like that. We had trouble calibrating it. The camera, the color camera with the structure sensor. And then we discovered that like iPhone 5s or 5Ss, their cameras would vary in their axis of mounting by up to 5 to 8 degrees.
They would be tilted. Yeah. The lens
like
tilt.
No reason, because there's no reason for them to be more accurate than that. Just like there's no reason for these Bluetooth radios to be more accurate.
Because they weren't doing computer vision stuff with them yet. Yeah.
Yeah. Ugh, what a nightmare. For a while I worked on I'm gonna pretend I was really smart. Okay, we'll skip past this ad. So I worked on VR was effectively commodity motion capture. So I was like, okay, well, what if I could do like live performance stuff at a distance? And I was kind of interested in like, well, what if you had made a Twitch stream that was more interactive, and you let people use AR to dress up and stuff like that, and could do sort of interactive shows. I'd done lots of immersive theater at the time, or by that time, and I ended up like founding a company that was focused on this kind of thing, where I would like, ship VR setups or setups to performers, and they would and people would sign up for time slots that they'd pay $15 to $20 for, and then like go play like a live video game where like one performer would play a bunch of NPCs. This is 2016 to 2019, before the pandemic. And it was very hard to convince people that this was a good idea.
What, you mean people are going to sit in a room by themselves? That's crazy.
Oh shoot. This room is about to be occupied by another meeting. I might need to
Okay.
run. Sorry.
Do we
I'm
do we do we do we want to?
I can find another room and just give me like 5 minutes. Sorry.
Okay, that's all right. We'll take a pause. There's a first time for everything. You know, it's thanks. This is why we don't have people from Mang on here. There's too many demands for their time. Satya, do you want to talk a little bit about?
I'll tell you about my user experience.
Yes, please.
Test, where we completely missed a few things. So this was back in 2012 or so. We were actually working on an iPhone app. Many people don't know that I founded a company right before this, which actually made virtual makeover for women. So women could upload their own picture and apply makeup virtually. One of the apps we built for iPhone, after we built this app, we obviously wanted to do user testing, and we got this. There were a few women on our team as well, so that we don't miss, because it was a beauty and fashion application. We didn't want to, a bunch of guys built it. So there were a few women who were also very fashion aware women on this team. So I was feeling very confident that things are going to be, we've got everything covered. And the very first day of user testing, I find somebody, she was playing with this app, but it was very difficult for her. And I realized that she had long nails, and I had not even, and so, the interaction was not, because of these long nails, it was covering things, and these could have been easily fixed if we had even anticipated this thing. And that's why user testing is super important. And, there are different levels. I also realized that there are different levels of fashion awareness. The women on our team, they were very fashion aware, but then there is a different level, right? Which our audience.
Fashion poisoned.
Well, so yeah, so that, but even very small amount of user testing, where you're testing with just 10 users, will tell you so much about things that you have completely missed. It's very useful. And we used to do this. We used to go to a university, San Diego State University close by, and do this testing. And we would, in an hour, we would go and ask a few women to test this app. And in an hour, we would get so much useful feedback, and we'll go back, come back again with just 10 people. With just 10 people, it's so useful to go and do this.
Yeah,
and
real life is just so incredibly chaotic and messy. There are more things on heaven and earth, et cetera, et cetera. You just can't possibly account for the way people behave.
Yeah. All right, let's get back to the talk.
Yeah, and sorry for that. I'm in a Meta office right now, and rooms get auto booked by an algorithm, such as the nature of life.
That's incredible.
Every manga company does it. So playtesting, everyone for sure, playtesting things are good. Even playtesting like a ticketing site and stuff like that. The thing that's frustrating, especially, is any gestural input. There's a mismatch between training data and how people actually use things, right? So, and that's like, institutionally, people who build training sets, I don't think we get it yet. We bias towards really clean data, and I think that's why self-driving cars are probably not going to happen in my lifetime, except on very special highways. But I don't want to get into that debate. But
preaching to the choir over here.
Yeah. There was I haven't shown this video, but I think this might be funny. I was trying to think when so I'll explain what's happening here before I play this. So when ARKit multiplayer was coming out, where there was the opportunity to do to be in the same space and play multiplayer games together, I was like, well, obviously the right solution to that is to use your phone like a percussion instrument. And so this is me and a friend, Alex, who played a virtual drum set. And so we're recording from his screen, and I am playing these instruments by tapping them with my phone. From my POV, from my phone's POV, obviously looks stupid, like I'm banging my head into this. But for the idea is that from the other person's POV, it looks great. This is
I remember that. I remember that WWDC. I was at that one.
Yeah, we built this like a month or two later, and then we were like, do we want to spend time trying to make this into a thing? And I had this stuff I wanted to do, he had other stuff he wanted to do, and then we were like, this maybe we will do it, and we just never did, which is too bad. But I had to do lots of like gestural kind of like stuff around that, like really careful like collision detection, because they'd be slightly out of sync visually. We had to play the audio at different times because there'd be like this like delay. I had to implement like the hysteresis around the different boundary sizes. Well, let's talk about what I'm working on now, and this is gonna be very brief. So, because there's just not much to talk about yet because we haven't released it all. Ask me again in a couple of years. We're gonna skip past this ad, of course.
Ask you again in a couple of years so you can dramatically take a drag off of an herbal cigarette and say, I haven't heard that name in years.
Yes. So this is an old demo from Control Labs in 2018. I joined them in 2019, and that's what our forearm-based band looked like, and we could detect gestures incredibly well. I have used so many different gestural interfaces, and I'm not just like touting my current work, but like it just works really well. It just works really well until it doesn't, but it works incredibly well. And this is just an earlier prototype. The things that were great about it is that it works well when vision falls apart. So it doesn't rely on a frustum. It doesn't rely on your hands being in view. The things work just as well in your pocket as they do while out in the world. And that is great.
And it's a watch kind of device, or?
I'm not going to use that exact word.
It's more of a forearm thing.
Yeah, it is our current version is around the wrist, and that's we've already announced that, but I don't want to like ascribe a specific utility to it. I joined, and 6 weeks later we were acquired, which is a very strange experience. Initially I was emotionally frustrated because if you've participated in startups, you join to launch a rocket ship. If you show up and the rocket is already launching, there's a little bit of like an egotistical thing of like, oh, well, what am I doing here?
What did I do?
Yeah, what did I do? Also, if you want to show that you're useful to a company, when you pretty early when you join, actually, just so you can figure out what the deal is. And if everyone's like, no, we got this handled, we actually like kind of solved everything, then you're like, oh, let's feel shitty. What can I do to be useful? Guess
I'll just keep cashing those checks and be on my way.
Yeah. Well, fortunately, the style of acquisition was okay, but you need to actually do it, which is very interesting. Now, if you've worked for startups or in research labs before, the reason why projects fail are usually lack of resources. And the lack of resources are like you lost a senior engineer, some other platform you depended on changed, a competitor shipped a product, and maybe it poisoned the well or something like that, or a better shipped a product and it's too similar to yours, or it has slightly different features. Honestly, most startups run out of like resources rather than competitors doing anything, because typically you are your own worst enemy. And often you're going on the cadence of like, well, we're trying to get to the next funding round, or we're trying to convince people to get to this next level. Well, what if someone said, oh yeah, whatever, just here's a blank check, do it. Do you need 500 or thousands of what you need? Here, do it. Well, what else you need? And it's a very different failure model, because now the failures are not around like running out of resources. It's like not asking for enough or allocating them incorrectly.
It's almost like having your bluff called, right? Exactly.
Which is both the greatest dream and the worst nightmare. But it's going great. So the stuff that's like interesting there is it actually works really well, except in cases when it doesn't. And when gestural interfaces are sort of like long tail interfaces. It's like kind of all the failure modes and exceptions that are
that need to be resolved, especially if you want something that works in the wild in messy ways when you're doing things. And that's why we do things like order 1,000 coffee mugs so we can make sure it works at various grip levels. But that's another thing that I don't need to get into. What's nice is also like all the stuff I did in my PhD, which all this like gestural interaction stuff is kind of relevant. Like I was very dejected at the end. Like, well, I don't think these will actually work, but I like gained all this special knowledge. So I was fortunate to end up in this position where like, oh, all this stuff I like learned, I actually need to do it now. And a lot of what I do is like, hey, that specific project I spent like a couple months on or a couple years on in my PhD and didn't work, do it again, but with way more resources. Yeah, so one thing I'd love to talk about is training data. And this is sort of interesting. So vision-based interfaces are often trained on synthetic data. When I say synthetic data, let's say you want to detect a school bus. You might take in 3D, and Uber actually has a pretty big artificial computer vision stack, or artificial computer graphics stack, where you like take a bunch of scenes, and then you take a bunch of 3D scenes. Those might be like real scenes, but then you like virtually put a 3D bus in there, and you rotate it, and you put it at different things, and you like add different lightings, and you move the sun around, and you like add different random headlights and stuff like that.
Synthetic augmentation.
There's also Carla. Carla is another company that is it is closely associated with OpenCV actually, which does car simulation or the driving simulation. So you could do all these things that you just mentioned. It's an open source stack. So if people are interested, you can check it out.
Yeah, that's carla.org. I'll post the link.
Yeah.
So pretty much every the final step will always be to validate on real data, but you can like train the first round of your models on all the synthetic data. And it's very easy to make this synthetic data. Like when I say rotate the bus and then add headlamps, you guys know exactly what I mean. If we ran up a simulation where I rotated the bus 5 degrees and we like looked at it, we'd be like, yeah, that's rotated 5 degrees. If we accidentally rotated it 5 degrees this way, vertically, we would like be like, oh, that's a bug. That's not correct. We also know how to render that. We've spent decades rendering 3D graphics, and there's a whole industry around rendering 3D graphics, games, movies, and stuff like that. So synthetic data for vision data sets is really easy. Even I think Uber has like a LiDAR computer graphics pipeline. Same problem, really. It's not visual data, but like if we need to change it into rays, we project into points. And to generate a point cloud, easy. That does not exist for EMG, for electromyography, for neuromotor interaction. I'm using those terms interchangeably. There is no rendering pipeline for electrical signals that muscles create. I would love if someone made one.
Right.
I've asked around. That doesn't exist. I don't know someone should work on it and then be bought for $1 billion. But so if a piece of meat in my body triggers an electrical signal, I have no way to render that, assuming I have an electrode at the skin surface. There's things that change. So like if I rotate my hand like this, that's not a smooth rotation. I'm just a bag of meat that's kind of floating around here. That's kind of stretching. So, first you'd have to model that. And then you'd have to model like signal transmission. Am I sweaty today? Are my muscles tired? Do I have a lot of hair on? Did I put the electrode in a weird position? And we don't have a way to do that internally. We have ways to take data and artificially kind of tweak it. It's called data augmentation, right? So you might take a picture of a bus and then crop it and then shift it 5 pixels left, but that's not really like rendering, right? That's like a hacky augmentation, right? Or another form of data augmentation might be like, I might take a picture of a bus and then I might apply like a grain filter to it, right? To simulate the camera being shittier, right? That's not rendering, that's augmentation. So we do some data augmentation stuff, but we don't have a way to render it. I would love if someone made that. But until we do that, we have to do all this like really mass scale data collection and model training, which is very time consuming. And so that's that's kind of summarizes up my thoughts on body tracking, which is a form of input, not necessarily vision, but it's really similar problems.
That's
And
interesting.
one more thing. So the first thing I worked on in HCI land in 2008 at an undergrad lab at Queen's University in Kingston. Was this professor had this idea that what if an interface was curved? So we bought this exercise ball and we attached like a keyboard to it, and we were like, well, how would you toss windows around it and stuff like that? We actually turned it into a fairly crappy frustrated total internal reflection table. We bought this, I think we bought this this piece of plexiglass from like a gardening company or a greenhouse company, and we applied this like really crappy gauze. This is an LED light strip around here that is putting that is filling this sphere with light. You need to be really careful about the radius of curvature here so that you have the total internal reflection. If you made the curvature too tight, it wouldn't reflect internally. So that's why we I think this might be sandpapered a little bit to create this rough surface. Anyway, it barely worked, but we have a video of it.
Orb.
Yeah, so I'm glad to share some orb content. This is a circular frustrated total internal reflection table from the Human Media Lab at Queen's University.
Gosh, just contemplate that orb.
Yeah, I thought the callback would work. So here's a vision system. This is not something anyone should actually use for anything. This is way too big. But there we are, 2008.
Interesting.
Tremendous. Thanks for bringing some orb content here. The only thing I like more than orb content probably is Simpsons content, and
Sadly,
one out of two ain't bad.
And that's all I have today.
Well, so some people may have another, time, at 10:30 maybe another stopping point for a lot of people. So
I have to head off as well. But if there's
well, I wanted to answer you to answer that question I asked in the very beginning. What do people at Facebook Reality Labs look for in a new candidate? And if somebody is planning to, apply, what are the kinds of skills?
Do you have any advice? How can they do as you have done?
Right. So applying for a startup versus applying for a large company are rather different. A startup is a lot more personal connection, and they're going to spend a lot of time investigating you and making sure that you get along, and they're more willing to do short-term contracts to like, hey, let's work together 3 or 4 months to see if we get along. Big companies don't do that. And there's a couple of reasons why. Because it takes so long to onboard someone that they might take 4 months to onboard. And especially because there's lots of confidential information, you're typically given tons of trust right away. The ability to break things right away. They err on the side of caution instead of they err on the side of a false negative rather than a false positive, which is frustrating. And the thing that's frustrating too is I'm typically on the other side of this. I interview lots of people now, and often we end up trying to find reasons why someone won't work rather than why someone will. So that's sort of like one thing, and that's just a frustrating part of the process.
You can turn off screen sharing so people can
sure.
directly. Sorry.
Yeah. That was definitely my experience at Occipital too. Hiring a lot of people, and we were like OpenCV when we were there. At least Occipital did a lot with a little, and it took a long time.
24, 48-hour project, and I think that's the best way to do it. But we don't typically do that. When I was at and there's a variety of reasons, So in terms of like large company stuff, the roles are generally divided along the lines of, are you a product manager? Are you a technical program manager? Are you a research scientist? Are you an engineer? And then are you sort of a design prototyper? Those are typically the buckets people are put in that you might end up at Meta Reality Labs. So mostly what I can talk about is if you're kind of in the engineer or scientist hat. if you spend a lot of time working on solo projects or at a startup, typically what happens is you're given a huge amount of trust and you're expected to solve an entire piece of the stack together. And you're like, okay, I'm going to submit a PR that updates the entire code base to do this one thing. You just aren't allowed to do that at big companies, unless you've been there for a couple of years. And the reason is because there's probably a bunch of people that have their own projects in flight, and they don't have their own processes, and there's like hundreds of Google Docs referring to the existing processes, and are you going to go around and fix them? And so what happens is you just need to spend a lot more time communicating and a lot more time justifying work. And then if someone comes to you and says, hey, I know you're working on this thing, it's taking 3 months, would it make sense to do it in 6 weeks? And what would you be able to cut? And if you're used to a situation where you have a lot more control, that often seems as like a meddling executive or like a hostile outside force who doesn't get it. And that's actually like a fairly unproductive attitude. I get it. I feel that way a lot of the time, but the amount of communication that's required and kind of justifying why something needs to happen is much higher. So the biggest thing we look for is like, can you communicate why things need to happen? Can you justify your choices? And can you negotiate change? And that's frustrating because often that requires a lot of direct experience. And the justifying your choices one is also a hard one too, because like I have a lot of like weird special knowledge, and I mostly work with neuroscientists who are used to building interfaces for rats that then kill them. And I have to be like, well, it needs to be responsive in this way, and it needs to be kind of squishy when you look at the target, and like it needs to respond this way. And they're like, I'll like mention that casually in the meeting, and they'll be like, could you write that down, please? Because that was very non-obvious to me. So I do like, I'm technically a scientist programmer, but I do lots of like writing of documents. And you have to kind of like that.
So for people in the interview process, right?
Yeah.
I know for sure that you have to be an exceptionally good programmer, and you also need to be able to solve programming puzzles and things like that. There is no getting around that. Recently, I know one of my friends who's at Facebook. He was vouching. They got a candidate, very good candidate. He loved the candidate, but he could not. The candidate failed the programming. Programming tests. So, and I've seen this with Google and others also, very strong candidates, exceptionally good, but somehow they fail these programming tests. So they have to be very good at programming, and especially programming tests, right? What other things do you look for during the interview process?
A lot of the communication stuff I described. In terms of programming tests, it's a really difficult signal. It is almost never like memorizing algorithms. Yeah. Almost never. A lot of it is around like, would I trust someone to do something, and would they communicate why they do something? And if I looked at their work, would I be able to tell what they did? So if you like, that's not fixed by adding comments to code or like naming your variables clearly, right? Like if you like watch someone work, you can sort of tell whether did they get to something correct that works right? Like, would I trust them to actually solve it? And like, if I had to come in and like do it later and deal with this later, would I be able to tell what happened and fix it? Like that's sort of the soft programming skills you look for. I mean, and the best way to get that is just to do tons of problems, like do tons of lead code problems, but don't obsess too much over like, stuff like efficiency or algorithm memorization, stuff like that. At least for like, the area I'm looking for, that doesn't matter as much, so much as like, would I trust someone to work with them, to work with. But, unfortunately, that's a really noisy signal. So like our on-sites typically have like 2 programming interviews. And we typically tailor those interviews to the person's area of expertise. But if they happen to like do ambiguously on those 2 interviews, sometimes we'll do a follow-up interview, sometimes. But like, we also don't want to have someone have a negative experience where we like do a couple of follow-up interviews and it's sort of ambiguous, and that just kind of sucks. So we'd much rather like, well, let's wait, like, I think there's actually a turnaround time of like, if we interview someone and it doesn't work out, we don't want them to apply again for a year or something. We don't want people to end up in like an application loop. But yeah, it's a frustrating thing. I'm sure there's a much more HR friendly way I could communicate that, but So I'm erring
One
on the side
last
of not
question
doing too
before
much.
we let you go.
Sure.
So typically how many rounds of interviews do people go through when, they apply, and what does the process look like?
Yeah, there's probably an official recruiter answer to this, but typically it's what we call a screener interview, which is just you talk to a recruiter, then there's a sanity check,
Smell test.
yeah, it's a smell test. You might talk to either, if it's an engineering interview, they'll get you to do a small bit of coding. If it's a prototyper, we'll ask you to like design something in 30 minutes or an hour. Or if you're a scientist, we'd ask you to describe a thing you worked on and how you solved it. And then we do what you might call a virtual on-site, which is where you just do a series of back-to-back interviews with 5 or 10 minute breaks for about 6 in a day. And then, rarely we will do a follow-up interview. And sometimes that follow-up will be like, well, we want to check your programming skills. We want to check some other like behavioral thing, because maybe it's like a manager role and we want to sanity check that you actually want this.
Right.
Sometimes we'll schedule another follow-up, which is called a cell interview, which is like, okay, let's make sure this person really wants it because we like them. Or we're not sure. We're not sure if they actually are into it. And we don't want to like, you don't want to hire someone if they don't seem that excited. Right. Then they might just like leave in a couple of weeks, and then it's very time consuming.
It's also possible to waste, because having been on that hiring side too, sometimes you end up wasting time on people because they're really just using you for leverage, like with somewhere else for like a better offer, right? Yeah, I mean, it's a bummer.
Yeah, but sorry, in skill sets overall at Meta Reality Labs, we're building things that are new that have never existed before. We make justifications based on data, but there's a lot of like instinct and willingness to experiment there. So the best backgrounds, at least for my team, are like a mix of like, can you prototype and do data science, and do you have a little bit of user empathy, and then can you like describe why you chose to do something, even if your description is like, I think this might be right, but I need to find out. So that's sort of the overall stack of skills. It's actually really hard to find people who do all
Yeah,
this.
in 2021, I've found that being a software engineer is a lot more thinking and talking and writing than it is writing code.
It's because lots of people make bad choices.
Writing for sure. Yeah, some other day I'll probably talk a little bit about why writing is so important. That's a lot of engineers don't focus enough on writing, explaining, documenting, etc. And when you find somebody like that, it's like you found gold, right?
Yeah. I do so much like I make group chats between person A and person B, and I'm like, you two need to talk to each other because you aren't. Here's what your comment is going to be. Goodbye.
Yeah, those connections are, people that make those connections are useful to have in orgs, Doc.
Yeah. And people start, when people you ask questions, a lot of times we end up seeing people writing as if they are writing tweets. That has become the standards. They'll explain, oh, why did you do this? Like a tweet. No, I want a document. I want 2 pages, 3 pages for you to explain why you did this. And instead we get these tweets. So
my DMs end up being fairly long. They're like what I call fire and forget, where it's like, here's the problem, here's everything you need to know to solve the solution. Here's what the follow-up should be. And then I just kind of send them off and like, don't need to look in again. I like that communication style. Almost like an email.
Yeah.
Gosh.
Who
would have guessed? Could this webinar have been an email, Doc?
Well, no one's going to read that.
Okay, so we are a little bit above time, but thank you so much, Dustin, for being on the show. We really appreciate the experience. You shared your experience. It was really great for our audience. Thank you so much for being here, and also the insight you shared about getting a job at Facebook Reality Labs. That will help a lot of people as well. Thank you. And thanks, Phil. And thank you so much, our entire audience, for being here. People who missed will get it on YouTube. Thank you so much.
That's right. Join us next week, Thursday. Joseph Nelson from RoboFlow will be our guest. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.